Now we have a little bit of a problem we have to work around here in the fact that we've been working over at Ken's shop, setting it up for his foam operation. At the same time, we're trying to get some of the parts for the I-beam Spitfire going. Now, one of the things I wanted to do on the I-beam Spitfire, and I'm looking at my books and magazines here, is I want to make a more scale nose. On the Spitfire, if you look from the top or from the sides, it's actually wider. We made the fuselage way too thin on the original models because we wanted to keep in keeping with the idea that they were stunt ships first, scale ships second. But I think one of the trade-offs we can make on this ship, since we're kind of going for broke, I think that's a saying Al Rabe used, is to widen up the whole fuselage. Now, my original thing was I wanted to take the motor mount. I wanted to use the same profile side view, but just widen the fuselage. And I wanted to take 3/8 by 5/8 mounts and lay them instead of straight up and down on their side, so that the weight would be the same, but I would in essence have a wider fuselage. And a wider fuselage, in theory anyway, should absorb vibration just as well or better than the thin fuselage. Now, that was the basic difference between the Seafire and the Spitfire, was the widening of the fuselage, and of course eliminating the turtle deck. But that's just one of many things, including a more scale-like tail, and I hope ultimately the wing will work out to where it'll actually look more like a Spitfire. We don't know that. Widening the body. I want to take the mounts again. It's a kind of simple thing. I'm not changing anything except laying 3/8 by 5/8 mounts on their side when I make the crutch. And because I can't really use the building table because I want to keep it open for finishing the Nobler and finishing the Brodak Cardinal, one of the things I can do is start making up fuselage parts. So in effect what I'm doing is making prefab parts for a kit, so that when the table becomes available I have a lot of this basic work done. Now, if you look at a scale Spitfire, and of course we're trying to go in the direction of more and more scale, you can get an idea just how wide that fuselage is. The fuselage is rather wide. And actually, I think this is a very valid, legitimate way to develop a plane, is to make the first one as much like a stunt ship as you can, and each one make it more and more scale-like up until the point when you seem to see performance drop off. And when you do that, of course, you go back a notch, and you know that's probably where your final version should be. But this is going to be the third one in the series, and each one has gotten a wider fuselage. I'm not even sure if this is going to become a late model or an early model Spit, but I want to have the option to go either way as I start under the construction. But I know in my mind I can picture that wider body, and I can picture some of the benefits of it. One of the benefits is should be a little bit better motor vibration, and that's always in your favor. It also will make a more scale-like taper into the spinner. What our taper is, you can see how on a real Spit this kind of drops right down. Well, ours looks a lot more like a bullet than it should. This should be, well, you don't know until it's all done, but it should really give a very dramatic impression, having that body a lot more scale-like. It'll be a lot more, in fact, like an Al Rabe type of plane, instead of the compromise that we've arrived at, where the planes are really stunt ships first. Now, if you go back and look at all the fuselage in the development series, these are the way these planes were made in this series. By getting each one a little bit wider, again, I think, needless to say, this one is more scale than this one, so I don't know. The next step up will almost have the whole tongue muffler in the body. I think that'll be kind of cool. And if we decide to go with the valve cover extensions like this, or these blisters, whatever you want to call them, I think it can really make for a real dramatic, very scale plane that would be almost scale except for the wing. Because again, we're going to try to do the tail also. But there's a lot of technology goes into making the nose of a plane. And all of these planes have used basically the same philosophy or theory, and what we're trying to do now is just take that to the next level. And I think it's just a good way to do anything, to approach it, as if you're going to make, let's say you're going to make Mustangs. Well, start with one that's almost a scale ship, and little by little work your way into having something that's a lot like an Al-Raid plane. And by doing that, you'll know for sure where to compromise is best and where it's going to suit your taste the most. Now, if we go too far, and if the plane comes out too scale, and we really lose a lot of performance, we'll know then that the number 2 plane, the Seafire, is about as far as we can go with this. But we're going to try to push it just a little bit further. And I guess for me, the whole fun of doing this is trying to get this envelope pushed. Always pushing for something a little bit more scale-like, a little bit more exciting than the one before it. Now I'm going to also try right to the very end not to commit to any paint job or any one Spitfire in particular. I want to have all the options open right to the very end, because as this project unfolds, and there's always a chance that this project is not going to be completed in time for the mats, and if it does, it'll mean I have the kit parts made and I'll be way ahead for next year's program. But we don't know where that's going. We might get snowed in and work on this for a month straight and finish it. I don't know. That's the whole fun of modeling. I mean, when we started the Spitfire in the very beginning, we had no idea where it was going to wind up. It turned out to be the most exciting modeling year of my life, for sure, working with Joe and with Bob Martens. And I remember thinking at the time, yeah, the fuselage is too narrow, but it's a stunt ship. And then when I went to the Seafire and said, oh yeah, there's no trade-off here at all. This was, if anything, it was better. I'm really excited about going to the next level here. And it seems like you really could. In fact, I should have done it on the Seafire. But anyway, with Joe kind of rounding out, finishing up his soon, we'll have a lot of neat things to work on come springtime. So let's go make a crutch. It's time. Trouble with these things is you got to get down the shop, get the saw out, get the mounts. You got to get busy. See, and again, that's the whole point of any of these semi-scale planes, is they have to capture that look, that thing that makes you stay up at night. When I think of all the planes, the Spitfire is one of the most attractive planes. To me it is. One of the planes that always makes me think, how can I make this just a little bit sexier, a little bit nicer, a little bit different? And that's why I am kind of inspired here. And one of the best things this gives us to do is, while we're working on the crutch and working on Ken's shop, this will all be drying out. And the longer I let this dry, the easier it'll be to buff out. And then we really only need about a day to put the motor, the push rod, the tank, and things on the wheels. And this will be ready to fly, so without further ado, let me go get the saw out. It's time. Anytime I start what amounts to be a new component part, one of the things I like to do is make sure, since I'm going to be working off plans, I don't want to have a big glob of glue or something up on a table. Get a new scraper blade. It's time for a new everything. A new XL blade, a new pack of blades, a new scraper blade. You want to do quality work, you have to have sharp blades, sharp tools, clean sandpaper, a clean table. Getting the table perfectly clean, because I'm going to lay last year's plans down here. I'm going to basically be working off interpolating last year's plans, side view being the same, and wider in the dimension, looking from the top and bottom, just a wider, more scale fuselage. And one thing, having a very, very good, accurate set of plans at this point in time is going to be a tremendous time saving, because I can work off. I have the crutch, I have the top view, I have the views that Bob Martens interpolated for me that are thus wider. But one of the things I want to make a quick note of for myself is, notice that on a D-tube wing, you have to cut a piece of the crutch away. Well, I don't want to do that. I want to have the mounts go right to the high point of the wing. So in effect, the mounts on this plane will go almost to the bell crank bolt, but I can mark that off based on where the bell crank bolt is here, and I don't have to taper this back because this is the way this wing is going to be made. So what I want to do is butt the back of this crutch right up to the back of the ring spar. And I can connect the ring spar then with the back of the mounts. That'll make it a very good joint, I think. I hope. Well, I guess we'll find out. It should be the right way. Anyway, and then from the back of that will be where the bolt can attach on. So building an I-beamer gives me a lot of choices here to make changes that, number one, make it a little bit more rigid, stronger, and lighter all at the same time. Again, remember that the mounts are going to be laid out sideways. Now remember, a straight wing I-beamer would have the spar in a whole different position. But that's basically where the position of the spar will be. So what I want to do, again, this takes a little bit of time to lay it out. And again, that's what's nice about having extremely accurate plans and templates. So now I know I want to have the crutch come all the way to this face. I want it all the way back here when I'm done. Now what I have is, just to make sure I had straight ones, I had 6 mounts cut oversized. And you can see, here's what happens. One is sprung already, so we're going to lose that one. And I assume out of 6 I'll get at least 2 good ones. But the first thing, these are 3/4 inch square. I'm going to have to trim these down to the size I need, the thickness. Now the first thing I want to do, I'll take a piece of, this is really going to be a scrap, I'll show you why. And this happens to motor mounts all the time when you cut them. You really just need to get a lot. Just like light balsa wood. It's got a banana bow in it. So I'm going to use this to set the saw guide. I want to lay out the length here. Going to use the same nose moment arm, of course, and we just want it to come back. The first thing I want to make sure is that the saw is cutting on 0. I don't want to make some kind of parallelograms here. Cut-offs, I just want to have the blade just a little bit higher than the wood itself. But this is the piece we're going to use. I can take the piece that's scrap now, and I can get a rough idea, since I want to lay these on edge, how much of that blade I want to disappear down there. Now I can take and put up the fence and just take it. This is just a test cut. This will establish the height. Then I can establish the side to side just by moving the fence. Now I want to measure this, and I want to make sure I can go around the whole perimeter to make a whole channel equal on this. That looks about right. Again, I can vary it. Now I want to go over one. You really need to do this in several saw cuts. Just go over one. Second part, I'm a little bit thicker than I want to be. So I get my first cut. If I go too far, okay, so for the first cut, I really can be over just. Cut this off just a tad. way too far over. This must have moved. You really should shut the saw off when you're adjusting this. That looks about right for the first cut. Now you can fine-tune. Obviously you have to fine-tune this width. And this width, it's a good idea to do it with the calipers. And I'll get all the mounts cut. And it's a good idea. Again, don't cut 2, cut 4 or 5 or whatever we can get out of that patch of wood. Because some of them are going to bow, some are not going to bow. But once you have the saw cut, set, cut a few extra ones. And you can see all the tests for fine-tuning the saw. Ultimately, you want to wind up with an equal channel wall thickness, and these will be side-mounted. Now also the dead stop, I've marked a little dead stop that I've used on the last 3 ships that allows the motor will be bolted up here. It's shown on the plans, and this is a gradual taper. It's not like if you did this with a milling machine, you'd have a 90-degree stress riser right here. This has a nice flowed-out cut because of the diameter of the blade. So we have 8 pieces. I'm going to cut 8 pieces to length and then start the saw cut ends. I've 8 of them to work with and see how many stay straight. You know some of these are going to spring. The ones that spring we'll just chuck, but out of 8 we should get 2 really good ones. Okay, now it's only a question of using one for a test. Use up one of the test pieces and set my dead stop for the end of the blade cut, since we have the first cut already programmed into the saw. Okay, I got them all chopped to length. I got the first cut in. Now, needless to say, the best way I've found to do this is to put the cut on the other edge and then just rip out the middle. But I think if you had a real woodworking saw, you could just move the blade over little by little and rip them down. Not really a critical thing how you do it, just to open up that slot to the dimension that you anticipate having it in the final dimension. Of course, I'll go down or out. I'm going to move the blade to the middle and rip out the middle. And once you get the saw set, needless to say, you could run off 100 pieces. It's not that big of a deal, but the object of making so many is I want to take the best, the ones that don't spring. And with wood, you never really know when you start hollowing and carving wood like this. All right, next step, reset the blade and pull out that middle piece. Now we got to go through the selection process and see which one of these is nice and straight and which ones have become pretzels. Now you can basically take one at a time and look for the 2 best. Ooh, that's a nice one. Now, if you really wanted to be fanatical, here's what you would do: is you take the two best,
And if you had more than two, you could weigh them. Although I don't think that would be really oh, that's a nice one. Now the most productive. Seems like a lot of overkill, but in the final product, yeah, we're going to wind up with more than two good ones. We're going to wind up with four good ones, in fact. That's a so we wound up with two sets that were not so good. They're acceptable. Let me just show you the amount we're talking about being out. If I squeeze these together, that's the amount they're out. One of the things you can do to try to salvage these or use them, you can tape them together against each other, which is what I'm going to do now to make up what will amount to be a set of spare mounts in case we make a crutch and we're not happy with it. Never hurts to have a spare set, that's for sure. Just back tape them against each other. The ones that are straight, you really shouldn't have to do anything about it. We'll get ready to mount the motor up. Got to find my old spare motor here. But this, if you put these in storage now, put them in a place where it's damp. Never put them in an attic. Never put hardwood in an attic where it's perfectly dry. You'll lose all the moisture out of the wood and they'll all turn to pretzels. That is a good tip, by the way. Always store your motor mounts in the cellar or where it's damp. And that should help get that little bit of a bow out of them. Through the natural process of selection here, we've arrived at having what I hope is going to be the two best from the 8 that we cut. I like to clean everything off and just slightly radius over the edges before I start making up the crutch. Gives me a good surface. The glue will get a good bind on it. I can even get in here and dust this out if I want. One of the most important pieces of the whole plane, getting the crutch nice and straight, nice and strong, nice and light, all at the same time. It takes a little more effort than just laying in some beam mounts, but it's lighter, stronger, and in this case, as we go to more and more scale look on the plane, we need to hollow things out. We can't make solid blocks, we can't make solid things that are unnecessarily heavy. So after all that work, we arrive with two pieces, and my double check is always just lay them back to back. And you can see that the things are both equal, nice and straight, they look decent, and ready to make a crutch. And again, on an I-beamer, we don't have to cut this away. This will add, I hope, some rigidity to the body. In fact, it'll change the whole construction of the body, but it should give us that nice big torque box for connecting the motor to the wing. The next thing is I always have I call it a dummy motor. It's a motor for making cowlings. I'm going to lay this out. In fact, I can work right off the plans here. I don't even have to worry about this. I can line up my bolt holes right with the plan. Okay, I just want to get a little CA on here. So just hold it in place while we're doing our drilling. This is what's nice about having these accurate plans, right on the money. Now what I do is I take the other motor mount, marry it right up to this one, make sure the slots are going the right way, and I want to very carefully marry this to the second one and just tack it on. Now with the glue holding it in place, it makes it real convenient. I'll go over to the drill press, just drill a little tiny pinhole here and get the self-tapping screws to hold these into the mounts nice and solid.
Once they're nice and solid, then I can drill the motor mount holes out, and because these are NC machined, they should be right on the money. Now, it's always important to get a screwdriver that has the right tip. These are little number 2 screws. If you don't, you strip the screws and the thing jumps off the head of the screw and everything. And a little pilot hole is important to keep from just stretching the whole mount apart. Using the drill press, I want to make sure I get these holes, of course, at dead 90 degrees, a couple of thousandths bigger than a 632 bolt, and then I have to back drill them for the blind nuts. The trick is to have the drill exactly the right size, a couple of thousandths bigger than a 632 bolt, that would be step 1, and having these mounts, you don't want them off to one side or the other, having this table nice and clean. Let the pad be the guide. This hole has to be opened up for the blind nut, and I think it's a mistake to drill a whole hole. I only want to relieve the back little bit so the blind nuts drop right in there. Now, before I put any CA on this, what I want to do is get a little bit of WD-40 and some chain lube, some kind of oil, and get some oil in the threads. Always want to run a bolt through. I don't want to permanently put them in there and get that whole hole full of CA, and oh man, what a mess that makes. A little bit of chain lube, any kind of grease will really do, but getting that little coat of oil on there before you go putting any glue on the nuts. Free tip, free lunch. Boy, that is the best tip. Now, before I go any further, I can put some thin CA down here and just let this wick down. Sometimes you split the mount a little bit. It really isn't important right now. The CA will seal that up nice. I like to build a nice thick bead of CA up around them. And now, hopefully, now that the moment of truth comes, if you can get the bolts out, if they come right in and out, that one isn't. See? So even with this oil on it, sometimes you have to use the wrench. And it's still better than having a sucker locked up solid. And sometimes they just come out. Depends how lucky you are. I guess it's like Clint Eastwood said, do you feel lucky today? Anyway, but I should go back now, before I go any further, and make sure that I have oil in all those threads. Well, I just hate the thought of, it just makes me crazy because I've seen it happen many times. And that locks up. Yeah, they're all okay. I'll go back and do these. Now I can bolt these right to the motor. Oh, it's a good idea to just hand tighten the bolts, not make them real tight. Bolt the mounts right up. What you want to get is a relative reading here while they're just snug, not tight at all, in fact. And you still have some variation, and the variation is that such. You can take this and move the mounts front to back and create offset. I want to keep this at 0, 0 for right now, but I can also take my machinist ruler
and get a reading on this using my finger for a dead stop. 221. Oh, geez, almost accurate, right on the money. 221. Once I have it kind of accurate, real carefully pick it up. Snug the bolts a little bit. This is one of the most important steps, is getting this nice and accurate. You don't want to have it V'ing out. You don't want to have it twisting up and down. 221, 221, 221. This is really important. You got to check that you have clearance right in this corner. Because you see how I moved the pad in a couple of thousandths? Because what will happen if it catches? Some of these Tigers don't have the right machining tool going down, and it's going to catch on the end of the mount and just spring it. So you want to make sure you've got a little bit of clearance. And if you don't, you can just dress off the mount, dress off the pad. But you want to have that little clearance. Just maybe the thickness of a piece of paper going down there. And what that does, that allows you to get some offset in when you go to fine tune. Once you know you have it all in alignment, you can sock the bolts down. Oh, I hear somebody coming. It must be Santa Claus. I'm just taking this right out over the drawing. Now you notice it's wider. It's the same length, the same height, but it's wider. And I can mark off now where all my little cross formers are going to go. To do is interpolate back here, because our crutch is going to be longer, basically because we're going to be going into this area of the fuselage, so I just interpolated these back. Now I want to strip off some 1/8 inch wood and drop all my formers in, and each time I do it, measure the crutch that I'm not bowing it out, bowing it in, or twisting it, or putting any kind of a twist at all in it.
Off into deep water right away.
That's the way you have to do it. You really can't fool around. Anyway, stripping these off, of course, is easy. Just set this guy the thickness of the mount. We're a little on the plus side. And, of course, we'll be using the good old XL self-healing pad. It's been good to us. All right, I'll just make up, and a good way to know if you're building a curve in is make a bunch of these up, as many as you need ahead of time. What's nice about doing it that way, maybe time for a new blade here. What's good about doing them ahead of time is you can line them all up in a stack, measure the end and the front, make sure you don't have any taper in it, and then from that point, when you drop them in, that should carry it right out nice and straight. I pin all these together, and then just make sure that they're a press fit in there. And I can just space them out. I have the spacing here, and I'll take a 90-degree triangle. Mark both sides so I'm getting them in nice and straight. Easiest way is to just drop one in at each edge, put a tack of glue on it. I like to tack them all in first, and then check my dimension down the whole edge. Then if everything is the way I want it, then I can run a bead of CA right down each one. This is why I like to mark both sides so I can get them all in. But it's always easier if you start at one end and work to the other, sometimes you can build a bow in even though they're all equal, but this is the best way I know of to do it. Alright, all I want to get is these leveled off on both sides. It looks like a little ladder for a dollhouse. This construction has worked well in the last, I guess, 4 or 5 planes that we built. The most important thing is check the whole length to make sure it isn't wider or thinner or whatever on one side than the other. Get all these screwed up.
step, I want to take a parting wheel and dress these off even with the blind nut so that I'm not tempted to later on put the motor in, put the bolt through, and it comes flying out the top of the top block or whatever. And then these will become a dedicated set of bolts for this model. Once I back these, you can see the ones that are in. Once I back these out, I'll dress that edge off, put a little more grease on each one of the bolts, put them back, just to make sure I haven't gotten any CA along the way or anything down in those holes. I want to establish that as a real good, that's got to last maybe 10 years, that set of threads that's in there. Let's have that razor edge on it. If you don't dress them off, they go in and booger up the blind nut. Just a minute or so to dress them off. Gets rid of that whole bar. Now I always start at the front. I guess that's the easiest way. Try to get a cross grain piece. This is 1/8 inch before I do any carving or sanding. Most important thing here is not to try to use up some 3-pound wood. Use it if you have a piece of sea grain. I don't, but if I did, I would use it up here. Get a nice solid glue joint on everything. If you have 4-inch sheets, it's nice, you have less joints. Most important thing, though, of course, is to have it, the grain is going side to side. Of course, I got these all block sanded relatively level. Now, after you put the sheeting on both sides, this gets really nice and stiff. It really gives you an idea of how this is engineered by how stiff it becomes. Once the sheeting, I'm going to sheet both sides, of course, but the side-to-side sheeting is the whole ticket. Now, of course, getting a nice glue joint inside here is another. As I'm going down, I want to get a nice glue joint in here. Okay, now what I do here, before I lay the top pieces on, I want to take this over to the belt sander and just dress it off nice so I got a clean edge to work with. Don't want to change the hardwood, just want to run that on the belt, get it nice and clean. Then I'll do basically the same thing to this side, so I'll have some 1/8 inch wood on that side, and that will then become my crutch. Now the belt sander dresses that off real nice. Now what I'm going to do is just reverse this, put the 1/8 inch wood on this side, grain to grain. Okay, the next thing, because this is going to ultimately wind up going up against a piece of plywood, I want to seal this whole edge with some thin CA. What that does, it gives it a glue surface to bond to. It also seals that joint between the wood and between the hardwood. The next thing is to lay this out over the spinner profile, and you can see this is going to be a wider fuselage for sure. You can see how much material I'm going to try to take away from the mount. And the curve should start right about at this point and end maybe leaving me an 1/8 of an inch on each side if this works out the way it looks. again, having the plan, knowing that this is going to be 1/8 of an inch wider, the curve is going to be more parabolic, and of course I'll have to make another spinner mold. I tried to lay red tape where I thought I wanted to get a little rough idea of how this curve was going to mount in here. But what I'm going to do is I'm going to put an ink line on here, very vague ink line, and leave the ink line on if I can, because I'd like to allow, so I'm trying to allow 1/8 of an inch or 3/32 for the plywood and what ultimately will be the fuse side, even though it blends into almost nothing in the front. I don't want to have it that it's smaller and I have to start building it up with Bondo. So this just allows me to look at the curve a few times before I actually pen it on, and then it'll be a question of just going and grinding it off with the belt sander. I inked this in, and I'm trying to look at it from directly up top to see if I'm close to having that line. Yeah, it's going to be close.
See, it's best. I'll leave a little bit extra on here, go test fit it, come back and I'll do the other side. But I want to see just about how that's going to work out. I don't want to go too far and then have to shim it or whatever. Before I take that last little bit off, I want to see if I'm getting down. I want to see what that shape in the front is going to look like.
With that done, I got to get a little idea of how much of this top 1/8 inch I have to grind away. I want to take away where the motor crankcase sits down in there, but leave in enough that this will be a bracing at least when I get the nose ring on. I just want to hog this out enough that the motor can drop right in. Now we're at the point, looking around here, I want to put a nice smooth finish on everything. This will basically be the heart and soul of the new wide body fuselage. And I think with this going right actually through the center of the wing, it'll add some rigidity here that we normally wouldn't have. I also wanted to make the crutch and I wanted to frame this up so I get a real accurate, even though Bob Martens has made me drill, because I have to space the center ribs. When I go to space them over the fuselage, they're going to be wider apart, and I don't know exactly what that dimension is, and they're in 1-inch increments, so I wouldn't want to, just like putting tile on a wall, I wouldn't want to wind up, and one is, just out of proportion. So this is really a critical thing. Even if I did have time in the jig and on the table to build a wing, it would be really helpful to have this, have the fuse sides framed up, and I will try to do that tomorrow, of course. And I would count for a day, though, for the first day of working on the fuselage, this has been a pretty decent day. And we have the little bones of the beginning of the I-beamer.
Here I am in the middle of making up a whole bunch of cowlinks with John Brodak, and look what comes in the mail. Just in the nick of time to inspire me to even higher ground. This is, from John Brodak, a great book. There's only one problem with the book. Now it's funny, a couple of years ago we got this fantastic book from Uwe Degner, and it was all in German. Well, now I get a book, and basically the whole book is in Japanese. I'm just kidding. Most of it's probably an Oriental book. I don't know. I didn't look at it yet, but it's got some really great detail shots. Just absolutely unbelievable stuff. I'll get a couple of close-ups of this. And it's a book by Always try to get the name of the company. You're glad I can see. Doesn't even name to me. Aero Details. Anyway, let me show this up close. It's got some cool stuff on it. And check it out. Here's the cover of the book. Well, I mean, this really is a nice book. I'm just kidding around about the... I assume it's Japanese. Maybe it's Chinese. Look at some of the nose details here. Again, you never have too many books, but here it's got some really, really... This is from the Battle... I'm sure it's from the Battle of Britain. I don't even have to even look. Battle of Britain was in. But look at the writing. I mean, if Kazminato ever comes over here, hey, we can have a ball. Actually, a true story about this is Kazminato is actually has Spitfire plans and is one of the people that at one time I think was really considering building one. Look at the detail on the exhausts, nose details, the kind of stuff you really can use. And it goes, this is what's cool about this book. Now, I only got a chance really to look at it after supper here. It picks a specific part of the plane and tries to give you details from a lot of different angles. This is the nose section. Obviously, we'd be working on that. Different nose sections. The lower fairing section, assuming you were doing a scale model. Look at the camouflage colors. Different cannon. Look at this different cannon arrangements. And anytime you look at a Spitfire, notice how thin the wing really is on a real Spitfire. Loads and loads and loads of decals, and I'm sure the reason John sent this, I know there's some really nice pictures, some real nice detail stuff back here. This is the kind of stuff we really always look forward to having. Some nice still photos. And look at this. I know this will make you crazy. We're always looking for unusual paint jobs. Here's a pink Spitfire, a blue Spitfire, the one that has the invasion stripes on the nose. Has the color chart here, by the way, with all the different colors. Some of the different aces. Another one. Look, just really, really nice stuff. John, I have to thank you. It's really great. And I'll be digging around looking for some, look at the motor on this, looking for some Focke-Wulf stuff. Pink Spitfire, now can you imagine? Just think about this room. If all else fails, we can make this one of these two. That's unusual, and I've never seen that before. That's the first time I've ever come across that. Anyway, I'm sure we're going to get some ideas from this book, and it will get added to the library. I was also real happy to see just how popular these fiberglass cowlings are becoming and how many of them John's been selling. Great little item. It's a nice little item for the world of modeling. Now this morning, I'm doing the mail first, and the first thing I open up is this picture from Bill Hummel. Gotta read you this. This is really funny. This is from Bill Hummel. Notice the picture. It's a cookie, in case you haven't figured that out. With invasion stripes. Bill, you need a little more room for the roundels. But anyway, listen to this. This is what makes doing all this videotaping worthwhile. Hi, Wendy. Sarah and I wanted to let you know how much we really enjoy your videos. We especially like the guest spots of Bert and Ernie. See, some of my competitors haven't figured that out yet, but we won't speak about that. Your house and family, etc. Please don't change them. Underlined. The other night we had dinner with Scott and Karen Smith. In our dinner we discussed an old Wendy video of you and Karen making a gingerbread house at Christmas. Yeah, we do that stuff. So you can see your videos are discussed, but not always for your modeling information. That's what makes them special. Additionally, when Sarah is upset or fussy, Sarah, by the way, is their baby, I think a couple months old baby, Bill and I found the perfect solution to calm her down. Windy videos. We put one of your videos in and instantly Sarah relaxes and falls asleep. Way to go, Windy. Hope to see you at Coxsackie. Anyway, that's about the kind of respect I get. Now, The end of the letter, this is really great. At the end of the letter, you can see, dun, 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 he's copied my thing, putting smiley faces. At the end it says, P.S. Please note the invasion stripes on Bill's Spitfire. It won't fly at Coxsackie since Bill ate it. Oh, Bill, I love it. Hey, hope the baby's fine. We're getting down to the shop. We're going to do some serious work today. It's a serious work ethic day. By the way, it's exactly that kind of letter that keeps me inspired and keeps me, I don't know, dedicated to making videos. Anyway, we had the crutch made. I marked off the spot, lined it up with the plans, marked off the spot where the firewall would go, and from here forward I want to put a piece of 64th plywood, because what happens if I don't do that, from putting the tank in and out, it's going to gouge us and the tank will never really sit nice and solid. When I look at the plywood, the grains, where you have the grain going side to side, 2 or 3 little laminations of this go side to side, so I want to lay out the piece so that the grain goes side to side. Yeah, and by the way, again, Bill, thanks for the letter. That cheered me up today. And what otherwise was a very somber day because of the death of my friend, my really good friend, Joe Cassie. Kind of on a downbeat thing here, but I'm trying to make the most of it. Anyway, again, I want the grain going side to side. That's a significant thing because 64th plywood, all 64th plywood, does have a superior resistance. In other words, it bends one way very easy, the other way it doesn't. I'd like all the strength side to side. I need to make this a 90-degree cut, and this will be the end of my piece. You want to get a good bond on 64th plywood. Because it's so peachy wood, I like to sand it down just a little bit and leave the dust on. The dust will tend to fill the grain and you get a much nicer bond. Now when I'm done, I want to trim the edges off, of course, and once I sand them in and run a bead of thin CA right along the edge to seal that, make a real good joint there. You can just dress that edge off right there with a sanding block. So you can just use the mounts for a guide when you do this. Got a couple of coats of CA on there. And what I want to do, I want to dress this back. I have a little, oh boy. President Nixon coming to sand your plane. Now the idea of doing this is just to make a little radius to get the tank to slide back in a little easier. I want to have a point there. And close it in and having a nice hand-finished piece here, a nice finished crush, and this will be the heart of the I-beam plane. And the next thing I want to do is I want to make up a Mylar template. Let me get this out of the way. I want to get a piece of Mylar, tape it over the planes, make a Mylar template of what I want the plywood doubler for this fuselage side to look like. It's not going to be exactly the same because in here we're not going to have anything but a hole for the belt crank cut out, and I want to run the plywood a little bit further back than I normally do on this type of ship because the side of the fuselage is actually going to hold the tissue and that half rib that goes in there when it gets built. So it's just a little bit different technology than building. When you build the fuselage for a plane that you're going to drop the ring in, basically through the body, you have a lot of different considerations of how you want to do it and what you want to do. This gives us just one more choice, one more different way of doing it, and I want to try to engineer it up as well as I can, of course. So let me get a piece of Mylar and we'll lay this right out. Now, I always try to supply Bob Martens, who does our original drawings, with real accurate information. A lot of times you notice, for one reason or another, you get a a plan in the mail or you buy a plan and it's not really as accurate as it should be. Well, what we try to do is work off the original parts that I use, same with the Spitfire and the Seafire. A good way to do that if you don't want to use Mylar parts is just make up a spare part for whomever is going to do your final drafting work. This is my way of doing it. This is a way that seems to work pretty well. How I can reverse this, I can use this as the top piece here. Save a little Mylar, this stuff is expensive. Now I know ultimately I'm going to need this piece cut out, because this is where the leading edge is going to go through. And I don't have the leading edge made up yet, so I can't get a real accurate cross section, so I'm just going to leave that as it is. And now that's the plot where that's going to wind up. I know the plot for my spar is going to be here. And what I'll do is I'll put the final cut in here. I'll just rough this out when I know. I'll bring the spar over here and use the spar. I just want to rough this out now. Boy, is it so nice having accurate plans. Oh. Anyway, I'm going to get the bottom edge of the fuselage in here. And none of this actually will change from the real plane. The original plane. Now see, one of the things I have to take into account here is the hinge line on the new wing has moved forward. So I plotted out the old part. This is where it gets a little tricky, not really, but I can work right off the rib, then I don't have to fool around. And I have the plot for the old one, and I have the plot for the new one. I'm working right off the rib, so you would think there's a real good chance, some chance anyway, that this will be accurate. Can plot the rod hole. A horn, plotting out the horn, I want to have some plywood support around the back of the horn with this kind of a design. Again, this has taken me back to the old days of sweeper technology when this was the way everything was done. Okay, I want to have an even amount of plywood around the whole piece. And again, by giving this to Bob Martens, what I'll ultimately wind up with is, I hope, a real accurate replication of the original plane. And that'll be a big service should we decide to make Spitfire 4 an I-beamer. We already have all these templates and plans made.
Now this is just one more good use for the XL Hobby Blade self-healing pad.
Cutting Mylar. Brand new blade. Piece of Mylar. Now, this is one of those tools that when you have the self-healing mat, you just find a lot of jobs that used to be a real pain just get to be a piece of cake, and this is one of them. Cutting Mylar is definitely one of them. Now Kenny has all those tools. Well, I can't wait to get my hands on some of those tools. In fact, I messed this up here. Let me get this over. All those nice pliers and everything. I want to leave some support around the bell crank.
I can actually use the spar itself to set up that spar slot that's going to be in there. This is one of the things that's kind of difficult about doing this the first time through is you don't really know. So in other words, I know that's going to fit on there, but you've got to lay out all the dimensions. It's not like just laying it out in midair, and I want to have that dimension as accurate as possible. I want to wind up with two pieces, one that I can send to Bob Martens and one I'll keep writing a file for myself if I need to go back and make a piece, or if somebody else decides they can't wait for the video or the plans to come out. So basically just transpose this down onto the other piece and slit up a spare. One will go to Bob, one will stay in the shop. What's real handy here is by making the parts in the sequence, I can lay out the crutch. I can see that the crutch is just going to end right at the spar where I want it to end, and I can interconnect that in there. I also can plot the new wing, the new center section of the wing, so I have plenty of room for the bell crank mount too at the same time. A lot of rhyme or reason, a lot of engineering, a lot of thought went into getting these parts in this sequence. Just think, by having this stuff all on video, how much nicer is this than having a magazine article where you have to leave out so much. Problem with a magazine article, you can't show a lot of this stuff. You have to leave too much up to the imagination. Okay, now we have a final pattern. We have a copy for Bob. I'll send this one out to him. Well, I guess I could make up the plywood doublers now. A little bit of time I have left. So these are the kind of mock-ups you can do now. Even when you have Mylar parts, you can lay these out just to get a little idea of how this is going to lock together. I want press and fit. I want everything to lock together as if it was laser cut. And it's always a good idea to use the actual, unless you're going to do the old cut, well, the other kind of ribs, strip ribs. This allows you to lay everything out real accurately right at this point in the game before you haven't even made a plywood doubler. You got everything laid out. Now, one thing will help. You're tracing this out, you can tape it in place with some masking tape. That always works. But there's an even better trick. And the trick is to make the first doubler and check, of course, that it's accurate. Go out to the plan and check it. And once you're happy with the first one, use the first doubler to make the second doubler. This way you're making a mirror image. And then this point on, we'd like to have mirror image fuselage sides, mirror image doublers at the same time. So we always use the first one to cut the second one, rather than use a pattern to cut two. You cut down the chance of error by doing it that way. Before I actually trace this out, what I like to do is check, get an even radius, the same size as a Dremel sanding drum, and that'll allow me to get some real nice, well, back here I don't want it, some real nice radiuses in here. I also thickened this piece up to 1/4 inch just to give me a little material to work on. And then when I actually get the bell crank in there, I'll have to obviously get in there and grind a little bit of that away, but this gives me a little more material to work with. Alright, next step, I got that new saw that I got for Christmas, which I've never used yet. I want to get familiar with that saw. This is the first time we're actually going to get to use this tool. And I couldn't justify buying another. I wear one out every year. I couldn't have justified buying one of those other ones. They're only about $40 more for this one. This one has a vacuum attachment that ultimately, if I'm not going to use it on the vacuum table, I can use that. Vacuum up some of the chips. It also has a little air bellows, I guess you call it, and a nice little safety gauge and everything. So I want to get familiar with the use of this. It's got a 2-speed on and off. Again, another useful tool I hope we'll be able to use all the time.
Seems like this saw works really, really nice. to work nice is this little foot that holds the work down. I just ran a parting wheel down the edges here to try to get a straight edge. I can pick away at this because it really would be hard to get this in by the jigsaw. That's the same thing for these cuts up here. This is a spot where you really should have a new blade. You probably could do this in a jigsaw, but it's just a lot quicker out here. You can always see it's coming through on the bottom, and you can always just catch it from the bottom to get a little bit neater cut. It's a good way to check that you have the hole a nice tight fit and that you're on center on both points. I'll dress this one off. I want to get a light sanding on this one. And I'll use this one to trace out the second doubler. I just like to always double check, make sure I haven't lost something in the translation. This looks like it'll be fine now. Again, the trick is to use this part to cut out the second line. Oh, this phone, I don't believe it. It's good when you're replicating parts too to work off a center line. Run that T-square down, put the center line on, just one little extra redundant way of checking everything's on center. Okay, next thing, I'll lay out the fuselage sides. Now I want to pick out some wood for the fuselage sides. 1/8 inch, obviously. Only one problem. I look at all the wood that I have. It's all graded and weighed. Take a close look at this wood and tell me which pieces you wouldn't use for a fuse side. See the two that are really bowed? So even though one of them is one of the lightest pieces we have, in fact, it's the second lightest piece, we'll lose that one. I certainly want to have the two straightest pieces for a fuselage. A fuselage side, especially the sides, you can really make a mess. Now let's hope we have some sea grain in here. I wouldn't hold my breath though. Oh yeah, this one. And let's hope the sea grain, even if it's a little bit heavier, here's a real nice light one, but look at the bow in it, look at the curve when you look down it. Don't want to make a fuselage side out of that. Now somewhere near the end here we're coming up on having some sea grain. This is not one of them. Ooh, we got two sea grains. And they're definitely they're almost the two heaviest pieces I have. I got them crooked here. Even though they have a bow in them, I want to put a straight edge and see if they spring. Now what I did, I superimposed the new tail, this is the drawing from Bob, over the old one. And I come up with about 1/8 of an inch difference. So what I wanted to do, I wanted to extend the tail moment arm 1 inch. So what will really happen here is the push rod will be 19 inches. 19 1/8 will be the new tail moment arm. I need to take that into account when I lay out the fuselage sides. I need to add an 1 1/8 to the total fuselage length. What we're going to do is be using a shorter span tail that's more scale, and because it has less cubic displacement, we're going to locate it further back from the center of gravity. It's pretty much a draw, but what we'll come out with is a more scale-like tail. That combined with the wider fuselage and the wing with 1,000,000 ribs. If we're really lucky, we can get into the front lotus here. Alright, time to lay this out. What I did, I laid this wood right from the middle. This is 48-inch wood, so what I did,
right at 24 inches, just put your finger under the wood and let the heavy side fall down. You want to cut off the heavy side. Now, I could tell without even, before I even did that one side of this wood was a lot heavier than the other. And you can see up in this end, the grain is a lot tighter, and out at this end, it gets nice and soft. Well, one of the things that I want to take advantage of is I want to cut from the heavy end. I want to cut off. So I want to measure. What I want to do here is measure, add on my 1.5 inches at the tail, and cut the heavy side off. That'll leave the heavier wood up in the nose, where it won't do as much damage, and get the lighter part of the wood back toward the back of the plane. Scott Smith did a little dissertation on this for his foam wings about putting the light wood on the inboard wing and this, that, and the other thing. And this is really a good way to do it. If you do this simple test, just put 2 little dots right where the 24 inches on a 48-inch wood. It takes only a second to do, and it can save you grams, free grams. Now, if you just lay a ruler down on a table, take the 2 little dots that were at 24, line them up on the ruler. Pretty obvious, that's the heavy side of the wood. So you know you want to take your cut off the heavy side. Let's put a little mark here. These are all little things that are really free. And even if you don't have the absolute best wood, at least you get to use the best part of it. Cut off the heavy end, use the light end. So what you really know now is you're cutting off the heavy end of the wood. Now you really could, if you wanted to make a jig, you could probably make a line in the middle. I wouldn't see which way it fell that way. Since we're only going to be trimming a little bit off of the sheet, I won't even bother doing that. Now, what I want to do is marry this up. I know I have the 2 heavy ends of the wood. I also want to get the big straight edge out, the 48-inch straight edge, and get a true edge on one side of this wood. So that's going to be the thrust line. And here's what I want to try to figure out. The wood is bowed just a little bit. It's bowed this way. I could true this edge up. Okay, I want to see if they both have roughly the same amount of bow, because I'd want to cut the bow on both fuse sides the same. So in other words, what would happen if it tends to spring, they tend to spring up or down, but not one up and one down. They're very close. They're within a 32nd of an inch. I'm not going to lose any sleep over this. But what I'll do is I'll assume they're going to all go up and work off a straight edge here. Get a brand new blade. Again, you always would want to trim fuselage sides as little. Of course, you'd like to start with perfect wood, but I haven't been able to find that in a long time. So this little piece now what I should have on my straight edge, I should have a real nice working edge. Okay, it didn't spring at all. That's real good. Now I'll try to replicate the same thing on this piece. Make sure I'm working off the right edge. It doesn't sound like a big thing until you figure out how much actual weight of the airplane is the wood. It's quite a bit, and anytime you can save it and not lose strength or not pay a penalty, it really amounts to be free lunch. Now, if these 2 pieces are a matched set, that looks real good. If they become a matched set, one of the ways of telling is put them together, and you should have almost no seam at all when they're brought together. If they're both straight, oh man. Okay, when they're parallel like this, I just put a little dot on them.
so I would know which is the two true sides. And it looks like, if you look real close, this came from a matched piece of wood because you have the two pieces here. The grain looks almost identical. Maybe this came from one piece of wood, I don't even know. But it is a good match. They both have one perfectly true edge now, and that'll be the top of the fuselage for right now.
Now on the true edge, I just want to touch that ever so slightly. Put a light sanding on the whole piece of wood, true it up. We're working off a nice true edge. We got a nice match set. We're ready to join the doublers, and it really
looks like we're going to have a nice set of fuselage sides. It takes a little time to get them this way. Well worth the effort.
I want to make sure when I join these doublers that I'm on a flat part of the table. Going to use the epoxy where one tube is twice the size of the other. But I want to start with a perfectly clean table. And one thing, always, double check that you're not making two left sides or two right sides. In our case, we'll figure out, here goes the plans. We'll figure out, I got the marks on here. I want to lay out a right and a left for sure. Heavy side of the wood up in the front, light side of the wood in the back. Now you might be thinking, why didn't I trim this first? Well, I figured I had a better shot at doing this without trimming it because I'm going to lay strips of carbon fiber in here. I can do that before I actually do the cutoff. I like to get the center line on the inside, even though I don't really need it. Just give me a reference point. And right now, if I can just trace these out on here, this will be fine. And I can do all the hole cutting after this is done. It'll be another little saving. Now I know how much Okay, this part here, I'll mix the epoxy up. What I like about this, using this resin, I can use heat. I can use the heat gun to squeeze out almost all the resin. If you're in rushing for time or something, I assume 5 minutes would probably be just as good, but using this gives you a little working time. The heat lets it penetrate real well. Like any epoxy mix, anytime you think you have it mixed, mix it a little bit more till the color's uniform. Since it's a little cold in the house, this is a little on the thick side, and that's where having a hairdryer and one of those squeegees will help. Again, we won't wind up with big globs of epoxy in there. As soon as you put any heat at all on this epoxy, it turns to water. And once you spread it out real nice too. Now the thing is, I don't want to get any epoxy up on the last maybe 3/4 of an inch, because that's where I'm going to have the bend in the mounts. Alright, that's pretty good. Spread it out, heat it, let it soak in. I want to make sure I take the right one. What I want to do is press, oh, I don't believe this. And press it all down. Make sure you got a good bond everywhere. Doesn't matter what oozes out. You can always get a little alcohol, a paper towel, and clean it up. But advantage now is we have a real nice thin layer of epoxy. It's missing a spot up here. You can see how nice that even that's spread out. Any spot that I'm missing. Well, it doesn't even matter if you go back and forth a few times doing this. The idea is to squeeze out as much of the epoxy as you can and not have big globs and blobs and who knows what. Another choice would be to do it with aliphatic resin. I'm kind of hooked on this epoxy deal. Okay. And when I get this one back on, line it up. Now just a little bit of alcohol, ordinary isopropyl alcohol. Get all the extra off. Even though we're going to cut that away, it won't even matter. And believe me, this is a lot easier than if you cut the pieces ahead of time and then you have to line the pieces up. Now you know they're going to line up because we'll just use this plywood for the guide. It's kind of like being able to attach the template to the part. Again, there's no glue up on the last inch of the nose so that I can bend that even if I have to ammoniarize it. I want that bend in the nose, puts a lot of strength in. Again, adds no weight at all. Gives you more freedom to add paint or details, cockpit details or whatever. In case there's some on the table here. Again, this is the other side. Always pull them apart and see that you have full contact. In this case, we are missing a spot. They really don't care. Whatever oozes out, just wipe it with alcohol. Don't let it just sit there. Get that paper-thin layer of epoxy. Now you know you have a pretty good shot at getting that full contact. We'll put this aside for a couple hours to dry. We got some other work to do today. We'll come back to this either later today or tomorrow when it's dry. Put some weights on this to hold it nice and flat. Okay, we're just going to let this dry. Put some weights over it. And while we're working on this, oh, just love hearing the heat come down on that cardinal. That paint will be so easy to buff out. Okay, time to clip these edges off. And I'll do that over the pad. The long lines I'm going to have to do over the glass. I need to copy this exactly off the plane so I get the exact same taper in the back. And then what I want to do is get the two fuselage sides together and make sure I have a perfect mirror image. And even though we had a lot of phone calls today, done a lot of phone time, been a good day. So you don't want to use the edge of the cowl. You get that nice clean edge. Now if you see a spot in here, and sometimes you do, where the glue hasn't really caught real well, what I like to do is get my fingernail in there and make sure it's nice and solid. But the best thing is then just seal that with thin CA along the whole edge. And it gives you a nice edge to work off too. Oh, I love it when the blades are sharp. Now we always accept the fact that, and this is an important thing if you're going to kind of design your own model, that you need about between a half and an inch, and in this case it's an inch because of the scale side view we're looking for. Spitfire tapers quite a bit to the back, but if we were making a cardinal we'd use a half inch. But notice how much this tapers. If you leave the whole thing flat, it'll always look like the plane is flying with its rear end down. So I want to get this, and again I'm taking this right off the plan view. There's an inch of taper, and then I'll be ready to marry up the fuse sides. Just want to dress that edge off. Make sure it doesn't spring. It seems like we're spending a lot of time on very simple stuff, but the truth is, this is the foundation of, let's hope, 8-10 years of flying, and I want to start with a firm foundation, all straight lines, everything even. Okay, now, here's the deal, and this will definitely save some time, is I use the one fuse side, try to get exactly a mirror image if I can. Now I can just rough this out. Yeah, without that 1 inch of taper, I've built several planes that had no taper on the bottom of the fuselage, and they always look like they're flying down. Look like old Ernie out there. By the way, I love that letter. I showed that letter to Karen, Phil Hummel's letter. Made our day complete. Made Ernie's day complete. Okay. And obviously, again, try to cut with the good straight edge. When we get done with this step, we want to get the two fuse sides married together. Make sure they're exact copies of each other. Mirror image copies, no matter what design you're making. This is really, it sounds like you're taking a lot of time to do this stuff. The reality is, it's a good investment. Now these two sides, first thing they should have is a pretty good parallel edge. You can't even slide a piece of paper in there. You should have, and they should be exactly even now. And if they're not, I'll dress the big one down to the small one size. And this is always a good way to get them as even as you can. Very handy having that sanding belt glued to the table. Okay, now I need to get a center line on here that I can work off. Just run the T-square right down. Now that's my accurate center line. That center line is running completely parallel to what will be the thrust line, so that all of the alignments of the wing are going to work off of this, the flap neutral, all of the alignments of the center pieces and the I-beam, all going to work off that center line. The next step, I want to cut all these little holes and everything out. Get a nice new brand new XL blade and get cutting. The key is sharp blades and of course the cutting mat. Now as we transpose it over, of course, I want to wind up right on center. Now I want to be real careful when I knife this out. I don't want to break. This is going to be a very delicate little thing until I glue the spar in. Again, these little delicate pieces. What I'm probably going to do is measure the thickness of the spar and make up a little sanding tool to get in here and get a nice tight fit. Okay, new blades. And now, of course, it's just a question of repeating on the other side. And you can think about doing is cut a nail file in half. Just cut it. Forgetting and dressing off all these little edges, and right in here, it fits perfectly. See how nice that dresses off the edges, the corners? It's a Bud McKnight trick and it works great. Nail files. Now in previous models we've used a strip of just tow and then laminated it into another piece of balsa wood. This time I wanted to try something a little bit different. This is 07 carbon fiber from Bob Violet. I was just going to say, be careful you don't get a splinter. I feel I just got one. Anyway, I just tack glued it in with thin CA. Thin CA seems to hold this well. Now I'll run a bead down the whole piece, but don't press it down with your bare hands. As I just said, probably you can see the splinter. Jeez. No. This is how things go here lately. Anyway, and I'll press it down. I'll get a squeegee or something to press it down with, rather than push it down with my bare hands. Seems easier if you tack it down first.
An alternative to this would be to obviously epoxy this in, but this is probably the last thing we're going to get done tonight. I hear Karen banging pots and pans, probably means it's time for dinner. So we'll just get this in tonight. In fact, I'll get the strip on the bottom in tonight and that'll be it. This seems to be a good way to squish out any extra glue. Squish, that's a nice word.
And what I hope that's going to do is the same as the toe. It locks it into a perfectly straight position. And then you don't have to worry about it. It's really in there more for the fact you don't want the fuselage in heat and as dope shrinks, slinking back and forth. Especially being we're going to be using molded blocks on this. There won't be a lot of extra weight up there in the molded blocks either. And the longer tail will need more torsional rigidity. So we accomplish a lot of things. We'll put two strips, one top, one bottom on this, and that'll probably be it for tonight.
I did the second one, attaching it with thick CA. And what I want to do is just run a bead right down the edge because it's capillary. It'll also harden the wood up right along the edge.
And an old trick to doing this,
See, if you sand this, what happens, turns the wood black and it looks messy.
doesn't hurt anything, it just looks sloppy.
And I know people like Banjock are going to be critiquing my workmanship here, so I want to keep it as neat as possible.
No kicker, I don't want any kicker around this. I want it to take a little bit of time to go off. I can also go along the edge here. See, that looks pretty good. That looks good enough, I won't even have to go over it. I can dress these edges off now just to get the little glue seams off. That is a nice little trick. I can take these two guys together. And then just dress them right off.
A little bit different building an I-beamer. Actually, the last time I built something similar to this was 1967. Can you believe it?
Well, it was earlier than that because I had the plane in 66. It was 65.
Wow, I must be getting old. Look it up in a magazine. Tell me what year it is.
Anyway, what we round up with, I hope, from a day of hard work is two really straight, really rugged, and really light fuse sides. And we'll be picking this up tomorrow. And so it's a pretty good day's work. See you in the morning. Oh, it's nice. Hey, before I retire here, I like to look around and just get a little feeling for tomorrow's work, a little idea. Possibly we'll get the correction, some of the formers started. And if I'm in doubt as to what I want to do, I'd make myself a little list so I don't forget. So what I do while I'm just waiting for supper to come out, make a little list of what I want to do to them. And from the list I can say, well, gee whiz, I got to lay out the formers, want to install the crutch first, pin the tail, and I look at this and ooh, there's something missing. Well, whatever it is, I can reorient my list. But having a list and having some parts prefab like this, will just give me a little bit more efficiency on getting things done on time here, since we really are. This is the latest I've ever started a plane in my whole life. Okay, this morning what I want to do, I want to lay the fuselage side right out over the plane and trace up all my former locations. Now I'll just put dots on here, then take a T-square and get a 90-degree angle down. I don't want to have the formers go up into the area where the push rod's going to go, so I'm going to calculate out exactly where that push rod would go, and I can do that right off the plan. Take into account that my tail moment is a little bit longer, and I can get a little sketch on exactly where the formers are going to go. It's easier to do this before I put the crutch in place.
Now this denotes just how far down or how far up the highest point the formers would go. Now from that line, now I can pretty much trace straight up, and I can lay out all the formers right in position. Just so nice, again, having good plans to work off. Such an asset.
Now where the dots are, I don't want to reference off the bottom because that has an angle up. What I want to do is take the T-square and each one of these get a 90-degree angle.
So I've accurately laid out all the formers. Then what I can do is, from this sheet, I can just trace it off onto the other one. Then I'll know every one is in at 90 degrees.
I just need to connect, really just connect the dots. I know the formula is going to end here. It's a real nice way to lay out the formulas, assuming you have a nice, accurate set of plans. I had to add one tail former, just because I'm bringing the tail further back out, I wanted to have one extra former in there. Other than that, everyone's a straight up replication of the original plane. What I want to do, I want to lay the other side back to back, put the dots on here, and then take the 90 degree so that I have an exact mirror image of the first one. And what I'll do is take the measurements off the first one, transpose them onto the second one. Okay, what we should have right now is a complete mirror image. Both of these have the formers marked. Everything should be, if I flip these over, there should be a complete mirror image of each other. Very important. And that carbon fiber really does help to keep it from twisting up or bending as humidity changes. Now I want to make sure I have a complete 90-degree angle on the crutch before I glue this in. And it looks like that's nice and straight. Now a good way to do this, let me hold it, is just put a couple of tacks on it and check it. Don't put the whole glue seam on. As that's drying, I just want to check that I haven't put a twist in it. Now you notice I haven't glued the last little bit, because that's going to bend up. I don't have any glue in between there either. I want to just get everything square first, and then I'll pinch this together. And if I happen to have some glue up here and this bends and breaks or crushes, it really doesn't matter. This is all going to get sanded into the spinner anyway. Again, a little check for 90 degrees before I lay up the other fuse side. Now when this is finally done, I'll just get some glue in there. Just get a nice soft block to pinch that and hold it while it dries. But in the meantime, I'm getting that curve in there. And that curve really does add a lot to the strength of the nose. And the most important part of this now is to get something to simulate the spar in here, because I wouldn't want to have one fuselage side ahead of the other. Get it in 90 degrees, and then I'll mark the crutch on this side. And then I can tack it in position. Once it's tacked and I can check it, I'll pinch the back of the fuselage together, make sure I haven't made a banana, make sure I have the spar in straight, and then run a final glue seam. Okay, that gives me a verification that I'm at 90 degrees. And I'll just mark this fuselage side with a little scratch so I can reference off of that. But there's a lot of good ways to build fuselages. There's all kind of exotic fuselage jigs, and they probably all work very well. But if this way works for you, the nice part about it is it's real quick and easy.
and no money at all. All you need is a flat table.
Once this dries, it'll pretty much be tacked in. I can go back and take a look at it. And if it's all okay, fine. If not, I'll just pull this one little glue seam apart.
Now, once you're satisfied you have the glue seam fine, you can run some thin CA down in here along the whole seam. Now, that's going to end at a box. We'll let it run all the way down, turn the fuselage over, let it drip back. And you know you've got that whole seam glued from the inside. You can do it on both sides, in fact. Which makes a nice way to get a really good glue seam in there.
So now let me just see if you can see what the gravity do to work. Once you're satisfied you have that. Now I just turn over and see that I've got a Now I stripped off a piece of 1/4-inch square, but I wanted to put a little bit of an angle on it. Because what happens, the fuse sides come back like this, and if it's square, you're always trying to make a good glue seam. Just put a little bit of an angle in it. Now you get to adjust. Make sure I got this the right way. There we go. You get to adjust the fuselage sides by sighting down it. And seeing, in other words, what you have, let me take this out, what you have the choice of doing is making a banana that way, a banana that way. You really need to just tack this in. I'm glad I got good eyes. You need to tack this in and make sure everything is parallel, and then sight it. And just put 1 drop of CA on here. A lot of times you have to break this 4 or 5 times until you get it exactly the way you want. And of course you want them both level this way too.
You can get a look at before you put a permanent glue joint there that you have the correct curvature. You could actually lay it right over the planes and see if it follows the curve of the planes. Well, one thing we really did work out on, I got plenty of nice C-grain 16th. And I'm going to make all the formers, the individual ones back here, absolutely positively C-grained. Grain going side to side. But first thing I want to do, I want to laminate this with the grain going in 3 or 4 different directions. And that can come right off the plan. 3 or 4 laminations until I get a nice former built up in here. I like to do everything with cross grain balsa, eliminate the weight of all the plywood, and when I'm done with that cross grain, it's absolutely just as strong as the balsa is. In fact, I can even laminate in some carbon fiber here, as long as I'm going to make a little sandwich of it. This is all detailed out on the plans too, except these formers will be just a little bit further apart, so I just have to take that into account when I lay them out. Now, I've just been told by the boss of our household, that this is all the time we have today, that we have something very important to do. It concerns food and the A&P, I think. Anyway, rather than get halfway into this, and this is something I want to figure it's worthwhile putting on the video. I hate to be in the middle of a job and stop. I hate to be in the middle of laying out formers and all of a sudden stop. So rather than do that, I'm going to pack it in for tonight. Also, we're actually at the end of the tape. We're going to put that all on one tape on the next tape. I don't want my competition criticizing that I'm having fun while I'm building or anything. Or that I stop. God forbid I should stop in the middle of a project. Hey, just kidding! Anyway, I think this is coming out real nice. This is going to give us a real nice, I don't know,
head start on what I don't know if it's going to be the 98 plane or the 90 plane or the 92 plane. Who knows? We don't know yet. But we're certainly going to try to really make this one special piece of equipment. And just having some of these parts prefab, like having that spar prefab, then having this prefab, when it actually comes time to lay the ribs in and put this sucker all together, it's just a whole different way of putting a plane together than when you use the traditional way. And I'm not even sure how I want to do this. I haven't really gone through this whole scenario for a long time. But each time I think about it, it gives me a little time to think about, maybe we can improvise some things along the way. I don't even know. I've been thinking about possibly we could use the old molds and just lay some 1/8 inch or 1/16 on top of them so that the molded shells would get a little bigger, like we want to make the fuse a little thicker. Thinking of all the things we can do, and every day I think about just what it could be. I'm real happy to get to this point, especially with all the things that have been chaotic in my life lately. I just think it's an exceptional thing that here we are. That clear is drying up right away. Just looked at that before. Everything is drying up, and even if we don't finish this plane for this year's Nats or this season, it'll be so nice being this far ahead. And I really want to make this something special. I really want to get the detailing on it, get the books right, come up with some real exotic paint job. It's all part of the fun. Anyway, we will see you on the next tape. The parts are starting to shape up, and when this starts to go together, that's one of the things I really have a lot of choices here is how I want to assemble this wing. But again, gives me some food for thought. Maybe I can improvise, come up with some new ideas, and even if I don't, using the old ideas will be fine. The old ideas from who knows when they invented I-beamers. It'll be exciting, I know. I guess it's just about this time in the beginning of starting up another one of these Spitfires. I have to thank this big guy here, Big Joe Adamusco. He was the inspiration behind the whole project. Believe me, without him, none of this would be possible. He is the man. Joe, you're okay. I don't care what Bob Martin says about you.
Special thanks to this guy too, with his DJ music blowing us away in the background. We got a lot of interesting stuff, and we can't wait to get to your contest, John. I hope everybody will make some effort to get out there, and we'll have a great week. Look at this, the phone doesn't even ring. It's unbelievable. You can't get away from this phone today. President Brodak calling. Anyway, again, thanks for joining us, and we just, at the end of each tape, I try to look around and think, how many wonderful things, well, how many great things we all have, how many reasons to be alive and to make the most out of the time you have, and again, sadly, during the making of this tape, Joe Cassie passed away, and I want to remember him always as a really, really good friend, an inspirational friend, and a craftsman. Joe, in fact, I think we're going to dedicate this Spitfire to you, ultimately. Thanks a lot. Thanks for being a good friend, Joe.